Let us see the next method of adding vectors, that is a parallelogram law of vector addition. So in this parallelogram law of vector addition, as you know, the triangle law is which method? Triangle law was head-tail method. This parallelogram law is head-head or tail-tail method. This is which method? Head-head or tail-tail method. That is, in case of triangle law, we were making the head of one vector to coincide with the tail of the other vector. Here, what we will be doing, we'll be either making the two heads to coincide or the two tails to coincide. So let us see the statement. What does the statement state? If two vectors are represented by adjacent sides of a parallelogram, then their resultant is represented by the diagonal of the parallelogram. Again, I'm telling what is the meaning of resultant. Resultant means addition. Resultant means addition. So here we will just represent the two vectors by adjacent sides of a triangle. So let us say you wanted to add two vectors. You wanted to add two vectors. So those two vectors, what you have to do is you have to represent them by adjacent sides of a parallelogram such that either the heads or tails are coinciding. Let me make the tails of two vectors coincide. This is say A vector. Okay, this is my A vector. And this is the tail of this vector. And I have one more vector. I have one more vector. Let us say that as B vector. This is B vector, and I'm making the tails of the two vectors to coincide. And theta is the angle between the two vectors. So how do you find the resultant? How do you find the resultant? What we have to do is we have made the tails to coincide. And now what you do, you complete the parallelogram. You complete the parallelogram. Draw parallel side for A. Draw parallel side for A and draw parallel side for B. Draw a parallel side for B. Let me call this as say O, this as P, this as Q, and this as R. So if this OR and PQ, they are parallel and equal. So if OR is making an angle theta with the base, even PQ also will make the same angle with the base. And then the statement tells that the resultant, the addition, is represented by the diagonal of the parallelogram. The resultant is represented by what? The resultant is represented by the diagonal of the parallelogram. This is my resultant. This is my resultant. And what do you mean by resultant, students? Resultant means the addition of the two vectors. It is A vector plus B vector. Resultant means addition of two vectors, A vector and B vector. I need to find out what is the magnitude of this. We just told the direction, isn't it? The resultant will be in this direction. I need to find what is the magnitude of this resultant. To find the magnitude, to find the value, if the length of this is A, isn't it? Length of the vector corresponds to the magnitude. So if the magnitude of this is A and magnitude of this is B, and if theta is the angle, then what is the value of resultant? It's not simply equal to A plus B. Then what it is equal to? Then we have to do some construction. So what we will do, we will extend this vector, OA vector. We will extend this and I'll drop one perpendicular here. I'm just doing some construction. Okay. And let me call this as say yes. Now, if this length is B, obviously this will also be B because the two sides of a parallelogram are parallel and equal. So OR and PQ will have the same value, isn't it? And similarly, OP and RQ also will have the same value, and that is equal to B. Now, how do I find that? Now, as you can see, there are two triangles in this. So what you do, you just separate out those two triangles. See, one triangle is O, two right angle triangles. Q and then S, OQ and S, and keep in mind that there is P from O to S. This is one triangle where this is the resultant, and then one more triangle is there, that is a PQS. This is the triangle. You can clearly check that there are two right angle triangles. One is PQS and the other is OQS. So two right angle triangles are there. So one more triangle is P and then Q and then S. So how much is this angle? Theta. And how much is the length of this P? Let us try to find what is the length of PS and QS. For that, we can apply some trigonometry. So you apply some trigonometry. What is the trigonometry you can apply? You find out what is sine theta. What is sine theta from the figure? Sine theta is nothing but opposite, which is nothing but QS, divided by hypotenuse. Hypotenuse is B. So from this, I'll get QS is equal to B into sine theta. I'll get QS. Now I can apply the trigonometry cos function and I can calculate PS. So you apply cos function, cos theta is equal to adjacent PS divided by hypotenuse. Hypotenuse is B. So therefore PS is equal to how much? B cos theta. So we had seen two triangles, two right angle triangles, particularly from the smaller right angle triangle, we found the two trigonometric functions sine theta and cos theta. Now from this triangle, you can apply what? You can apply Pythagoras theorem. So what does Pythagoras theorem states from this? Pythagoras theorem states that the square on the hypotenuse. So according to Pythagoras theorem, OQ square is equal to OS square plus QS square. Now, what is OQ? OQ is nothing but the resultant value. So R square. Now, what is OS? As you can see, OS is nothing but OP plus PS. And what is the length of OP? The length of OP is nothing but magnitude of the A vector, which is A. And PS we have already found here, B cos theta. So OS is nothing but OS. If I split up, I can write it as OP plus PS the whole square plus QS square. Now, what is OP plus PS? So OP is nothing but A and PS is nothing but B cos theta. PS is nothing but how much? B cos theta the whole square plus QS. What is the value of QS? QS is nothing but B sine theta. So B sine theta the whole square. Now this is in the form A plus B the whole square. This is in which form? A plus B the whole square. What is A plus B the whole square value? A plus B the whole square is A square plus B square, B cos theta the whole square plus 2 into A into B. B instead of B, we have B cos theta. I'm just using this identity A plus B the whole square is equal to A squared plus B squared plus 2AB. Instead of B, we have B cos theta. Now, and one more is there, B sine theta the whole square. We know B sine theta the whole square is for both the terms. So we can write it as B square sine square theta. And then this will be equal to A square plus similarly we can write for this. We can write square is for both the terms. So B square cos square theta. And I'll write B square sine square theta over here so that we can take out the B square common. So B square sine square theta plus 2AB into how much? 2AB multiplied by cos theta. Now from these two terms, I can take out B square common. So if I take out B square common, what will be left out? If I take out B square common, left out will be cos square theta plus sine square theta plus 2AB into how much? Cos theta. Sine square theta plus cos square theta, we know it is 1. Therefore, the resultant value is going to be, send the square that side, it is going to be square root of A square plus B square into 1 B square plus 2AB cos theta. This is the resultant value. Resultant is not simply equal to A plus B. What it is equal to? It is equal to root of A square plus B square plus 2AB cos theta. This is the magnitude of the resultant. This is the magnitude of the resultant. We were telling no, resultant is not simply A plus B. Then how much it is equal to? It is equal to root of A square plus B square plus 2AB cos theta. Now, it is not enough to specify the magnitude. We need to specify even the direction. So how do you find the direction of the vector? To find the direction of resultant. Now, what is the meaning of direction of resultant is? It means you should tell how much angle the resultant is making either with the base A vector or B vector. That's the meaning. What is the meaning of direction? What is the meaning of direction? Direction means you need to specify how much angle the resultant is making with this base A vector or B vector. How much angle it is making. So that will be called the direction, the angle made by the resultant with either A vector or B vector. Let us say angle made by the resultant with the A vector is alpha. How much is the angle, students? Angle is, let us say, alpha. Resultant is making an angle alpha. So this is that alpha. Resultant is making an angle alpha. So how do you find the direction? You apply some trigonometry now. Let us apply tan function. Usually we make use of tan. You can also apply sine or cos. So let us take tan. So tan alpha from the figure is going to be opposite, which is the opposite QS by adjacent. Adjacent is nothing but OS. So how much is QS? QS we know. QS is equal to how much? We have already seen QS is equal to B sine theta. So it's going to be B sine theta divided by OS, as we had split OS as OP plus PS. OA is nothing but A and PS is nothing but B cos theta. This is the formula for direction of the resultant. You need to specify how much angle the resultant is making with the base. So alpha is nothing but alpha is with respect to A vector. You can also take B vector, doesn't matter. So I have taken with respect to A vector.